The data center sector is being reshaped by AI acceleration, shifting infrastructure constraints, and evolving customer expectations. In this video, I'll walk through 5 key trends that are transforming how data centers are being built, operated, and positioned in the digital economy. Firstly, infrastructure build-out is accelerating, but utilization remains uncertain. The pace of deployment across the sector continues to increase. Hyperscaler capacity has doubled annually for the past 3 years, with a further 40% uplift projected in Europe by 2026. Billions are being invested into land acquisition, energy access, and supply chain resiliency as developers race to keep up with demand. However, delivery is still constrained by non-monetary factors, chiefly power transmission limitations, skilled labor shortages, and permitting delays. While capital is available, these practical barriers continue to throttle project timelines. Yet, where there's a will, there's a way. Operators must remain alert to competition from highly agile entrants. For example, xAI's Colossus facility was transformed from a brownfield shell into a ready-for-service data center in just 122 days. Similarly, Grok's 51 contract live delivery of its LPU-based IaaS platform for Saudi Arabia's AI leader, Humane, demonstrates that greenfield market entry timelines can now be measured in weeks, not years. Much of this current investment is being driven by expectations around the shift from AI training to inference. One global AI infrastructure leader is already reorientating around GPU-heavy inference workloads, anticipating a more scalable, transactional phase of AI that may dominate enterprise compute in the years ahead. One forward-looking forecast even places inference at over 90% of enterprise AI workloads. But despite these early signals, this remains speculative. Many industries face internal cultural barriers to AI integration, including within data center operations themselves. And amid this uncertainty comes a new cautionary term, braggawatts. It refers to inflated, often unsubstantiated capacity announcements. With energy transmission, not generation, becoming the true constraint in many markets, bold projections must now be grounded in delivery reality. Secondly, power gets the headlines, but interconnect may be the critical bottleneck. Power availability remains a dominant theme, but many operators are beginning to recognize network interconnectivity as an emerging constraint. AI workloads are no longer confined to centralized training clusters. Instead, compute is increasingly distributed across a network of interdependent facilities, each with varying degrees of readiness. These infrastructures must now support systems that operate autonomously and exchange data across multiple domains. This shift is particularly evident in sectors such as mobility and logistics, where autonomous vehicle fleets are projected to generate continuous streams of video, mapping, and sensor data. These data flows will originate in dynamic, geographically dispersed environments, placing new demands on network aggregation and routing, not just on power consumption. Traditional assumptions about centralized compute are no longer valid. As AI agents proliferate, infrastructure must be designed not only for users, but for systems acting independently of them. This introduces a new layer of architectural complexity, where the performance, redundancy, and design of interconnects are as critical as those of data center sites themselves. As data center expansions pushes into new geographies, often driven by power availability or national digital agendas, the distance between data generation, processing, and output is widening. This will require coordinated investment across the value chain between data center developers, network service providers, and enterprises. Thirdly, public perception is now a material risk to delivery. Permitting and site approvals are increasingly influenced by community sentiment. In some markets, local opposition can delay projects by months or even years, undermining internal rate of return and driving up delivery risk. Modeling from STL Partners shows that a 1-month delay on a 60 megawatt facility in the United States could cost up to $14.2 million. With margins tightening, project teams are now treating local engagement as a core risk to manage, not just a stakeholder formality. Recent research by CyrusOne indicates a significant awareness gap. Across Europe, while 93% of survey respondents report a neutral or positive view on data centers, only 52% can accurately define what one is. In the UK, that number drops to 38%. and among 16 to 24-year-olds, fewer than a third recognize the role data centers play in their daily digital lives. This disconnect is no longer benign. As scrutiny increases, particularly around environmental impact and land use, operators must embed public engagement into delivery planning. Effective strategies include early consultation on biodiversity, transparent communication of job creation, and design tweaks that reflect local values. Even minor changes, like adjusting facade materials, can help build trust. The shift is clear. Community relationships are now a key delivery variable. The industry must move from a compliance-driven mindset to one that prioritizes local collaboration and trust building. Fourth, sustainability remains core, but regulation is misaligned. Sustainability is now embedded across the sector. According to the European Data Center Association, 94% of European facilities are powered by renewable energy. Many hyperscalers continue to lead, with strategies focused on additionality, supporting new clean energy projects rather than relying on offsets. In parallel, investor expectations have matured. Today, carbon transparency and clean sourcing are baseline requirements, not competitive differentiators. However, dissatisfaction is growing around the current policy environment, particularly within the EU. Several regulations have been described as administratively burdensome and mismatched to real-world environmental performance. Notably, sub-500 kilowatt facilities, which may have peak PUEs above 5 or even peaking above 11, are often exempt from the most stringent efficiency mandates. Meanwhile, larger, more efficient operators face complex compliance obligations that extend beyond PUE to include reporting across multiple dimensions, some of which are relevant to sustainability. There is now a clear call for targeted, outcome-driven regulation, incentivizing actual performance improvements rather than box-ticking exercises. Regardless of policy evolution, sustainability remains non-negotiable. Operators must continue to invest in energy efficiency, water use and optimization, and emerging metrics such as energy reuse factor, ERF, to meet customer and investor expectations. Fifth, design norms are evolving, and flexibility is the new strategic imperative. The final trend is a shift in design philosophy. The speed of architectural change, driven by AI hardware evolution and workload volatility, is outpacing legacy infrastructure models. If current guidance holds, rack densities could reach 600 kilowatts by the second half of 2027. This renders traditional cooling and power configurations inadequate. Liquid cooling is rapidly moving from proof of concept to scale. Operators are now deploying direct chip cooling and, in some cases, full immersion. But these systems come with operational trade-offs. Liquid cooling provides just 30 seconds of ride-through protection compared to 2 minutes with traditional air systems. Many operators are now delaying final infrastructure decisions to preserve flexibility, recognizing that architectural standards may shift within the construction timeline itself. Some facilities are designing around peaks that occur for less than 40 minutes per year, prompting debate around whether traditional redundancy models are always justified. For workloads such as AI model training, momentary downtime may be more acceptable if IT layer solutions can mitigate the impact. There's also growing interest in agentic AI systems managing facility operations in real time. While trust, uptime, and cybersecurity concerns remain, adoption may accelerate once a leading operator can demonstrate resilience in a closed-loop cross-domain automation model. Hyperscalers continue to lead on efficiency, with self-reported PUEs of 1.15, compared to 1.39 for colocation and 1.85 for enterprise facilities. Their end-to-end integration allows them to shake rack reference architectures and standardize thermal and electrical profiles. Co-location providers without these advantages risk being left behind. In summary, the data center industry is entering a new phase, defined by rapid infrastructure growth, increasing architectural complexity, and shifting expectations from customers and regulators. Operators are being asked to deliver faster, build more flexibly, and operate more efficiently, often all at once. Navigating this environment will require sharper foresight, more adaptable infrastructure strategies, and deeper integration between facility and IT layers. Ultimately, the data center is no longer just a neutral container for compute. It's becoming a dynamic, evolving enabler of the AI economy, and the ability to anticipate change, not just respond to it, will define which players lead the next chapter of this industry.